Hello, biology class. This is Jokum. You may know me as Jane. Shame on you if you remember me by my ID number. That's just wrong. But anyway, we're not going to get into that today. I'm going to teach you about my favorite element. My favorite element is mercury. Mercury is just amazing. I mean, it's liquid at room temperature. It's basically normal metal, except that its melting point is shifted. So, I mean, if you cool it in liquid nitrogen, it turns into a solid just like a normal metal. But, actually guys, I'm not going to talk about mercury today because it's actually quite poisonous to most living organisms, including us humans, and that's why they don't make mercury thermometers anymore. Since I can't talk about mercury because it's not very essential to life, I'm actually going to talk about another really cool element, and that's sulfur. Sulfur is a really cool element because in pure form it's a very vivid yellow color, and most elements on the periodic table don't have a color at all. Well, I mean, they have a color, but it's usually just like a gold or silver, or maybe some other dull form of those colors. But sulfur is a very yellow, vivid color, which is very unique for elements in pure form. So actually, this is actually a sample from a chemistry kit that it's sulfur powder. Here's another sample I have. This is native sulfur, which I believe it's larger sulfur crystals mixed with, I believe it's quartz. Sulfur is located here on the periodic table, and as you can see, it's abbreviated with an S, and its atomic number is 16, atomic weight is 32, and it is located in the non-metal section on the periodic table. Non-metal means that it does not conduct electricity, which sulfur does not conduct electricity. Here's my model of a sulfur atom. In the middle here we have our representation of the nucleus, which is made up of 16 green grapes and 16 purple grapes, and the purple grapes represent our protons, the green ones represent our neutrons, and then around the outside we have our electrons in their different orbits. So we have in our first orbit, which can hold 2 electrons, we have one here and one here, which makes up 2 for the first one, and then our second orbit is full with 8 electrons, which is this orbit here. So there's 4 on this side, 4 on that side. That's the second orbit, which is full. And then we have our third orbit, which can hold another maximum of 8, but we only have 6 in it because there's 16 electrons. So we have 3 on this side and 3 on this side, making up 6 in that orbit. So that is my sulfur atom. Sulfur has a melting point of approximately 239 degrees Fahrenheit and a boiling point of approximately 832 degrees Fahrenheit. Now, as you will see in a moment, sulfur actually turns a blood red color when it is melted. And I'll just heat it up with this flame here for a minute, and it should turn a nice red color. There we go, it's starting to turn a little bit red. There we go, it's starting to turn nice and red now. So it almost looks like it's glowing, which is actually not hot enough to glow. But it's, as you can see there, it's a nice red color. And as you can see, after it's cooled back down, it's gone back to its nice yellow color. Sulfur has been known since ancient times and is called brimstone in the Bible, which means burning stone. Not only is sulfur essential to life, it also has many uses in industry, like in the making of sulfuric acid and as a main component of many fertilizers. Sulfur is also in body fat and bones. Sulfur is special in the sense that it can be found in nature in pure form and is often around the vents of volcanoes, where it is still often obtained in poorer countries by sulfur miners. Sulfur was once extracted from salt domes, but today almost all sulfur is produced as a byproduct of removing sulfur from natural gas and oil. The sulfur-containing compounds in oil and gas are removed because when they are burned, they produce a lot of pollutants that contribute to acid rain and are quite toxic. There is a really neat place in Canada that has a long-term storage of sulfur that has been removed from oil from the oil sands that come from Canada. Sulfur burns with a blue flame combining with oxygen to form sulfur dioxide, which is known for its suffocating smell and toxicity. Plain sulfur has an odor very similar to that of matches. In fact, a lot of strong smells are actually caused by sulfur compounds. To name a few, onions, garlic, a chemical they add to natural gas to give it a smell, burning hair, skin, and feathers, and many rotting processes all have smells that are caused by sulfur compounds. I hope you learned something or found my video interesting. Thanks for watching.